we've looked at how to find some sides, and looking at the class kicks, looks like we're doing pretty good. Just got to watch when the denominator is on the bottom that you remember to switcheroo. I had to correct a couple of people on that one. Apart from that, we're going pretty good, but I got a lot of questions about the degrees. I think it was 24 degrees in 5 minutes. So as you can see above me, I've got a calculator emulator. And so hopefully we'll be able to talk about that, and I can show you which buttons you're supposed to be pressing. So before we go on to finding unknown angles, it's probably worth discussing these angles for a bit. I won't write any notes, but if you feel like you need to write it down to remember it, then go ahead and do that. But it might just be best to practice along and press some of the buttons. Now, let's say I had 24.5 degrees, 24.5. That's the decimal way of splitting up part of a degree, but that's not always how it's been done. Often in the old times in navigation, when 6 was used a lot more, hence why we've got 60 minutes and 360 degrees in a circle, etc. Because 60 is very divisible by things, which is why it was used a lot. I think it was Babylonians back in the day. What they would do was also split up degrees into 60 parts. So each degree, this big or something, and then you'd have to split up even further into lots of little parts. And those little splits were called minutes because there were 60 of them. So that's going to present some different challenges for us, but they didn't just stop there. They also split up those minutes 60 times again. So we're talking tiny little fractions of a degree now, and they called them seconds because it was split into 60 as well. That means that we can use this button on the calculator here for both degrees, minutes and seconds, but also for hours, minutes and seconds. And that could simplify a lot of your time calculations if you want. Now, just like, let's say this was 24 hours, 0.5, we would know that means 24 hours and 30 minutes. And it's just the same for degrees. The handy thing is this button here converts it for you. So I've already pressed equals, it's already here, otherwise it won't work. Press that button and look at that. Just like SD converts to fractions, or shift SD to go to proper fractions, this one here is going to convert between degrees, minutes, seconds and decimal. Just a little note as well, I never talked about this, but your calculator can actually be in lots of different modes. Degrees isn't the only way of dividing up a circle. If you're getting some weird answers, just try reset your calculator, shift 93 equals, and make sure it's got the D for degrees up the top, not R or G. Now, 24.5 we saw became 24 degrees and 30 minutes. It's worth noting, if it was 0.5, we would know to round up to 25. But here, 30, the temptation is to round down because it's less than 5. But just remember, minutes and seconds are out of 60, so if it's 30 or higher, we're rounding up. That's going to come in handy when the question might be something with a result of, say, 24 degrees, 30, actually let's do 29 minutes and 32 seconds, something like that. And it will say round to the nearest minute, and 32, well, that rounds down, we mostly think, so we'll write 29, but that's actually incorrect. 32, remember, is out of 60, so it will round up. Now, that's a little prologue done. If you already knew all that, sorry, I probably should have told you to skip to this point. I'll put it in the email, but finding unknown angles. As you can see, the angles are going to be pretty important in this case. So, same 4 steps. Label the triangle, find the ratio, write the equation, solve the equation. The last step, solve the equation, again, is the different one. And there's something important we're going to have to learn on the calculator, as well as remember to do it. because it's new and it's going to look a bit funny. Let's do it by example though. So EG, find the unknown angle. Alright, so I'm going to use my symbol theta because we often use Greek letters for angles. And let's say I know the hypotenuse is 12 long, could be meters, and then let's say that side is 5 meters long, and we have our right angle. As I said, the first steps are exactly the same. First of all, we're going to label the sides. Well, if that's the angle, that's the hypotenuse regardless. That's going to be opposite the angle, and that's next to or adjacent. I've got the 5, I've got the 12. Those are the two sides I care about, which are O and H, which leads me to use sine. This time, instead of writing a number, because I don't know it, I'm going to have to write my unknown, theta, equals. Now this is where a lot of us got tripped up. We got the right ratio, we just put the wrong one on top. Remember, SOHCAHTOA is in order. Sine equals opposite, which is 5, over hypotenuse, which is 12. When we're finding the side, that's going to really help know whether you use switcheroo or not. Now, sine theta equals 5 on 12. That's my equation. Now there's only one step from here. I just need to solve it. And it is a one-step equation. I need to get rid of sine because I want theta by itself. I want it to say theta equals 20 degrees, say. Might be somewhere between like 20, 30, around there, just looking at it. We need to find it out, so I need to get rid of sine. Now, just like when, let's say we had x divided by 12, we need to do the inverse to get rid of divide by 12, and the inverse of divide is times by 12. Just like that, there is an opposite of sine. Now, when I ask the class to guess this, they always say cos. It's not. It's just called inverse sine. What we would do is we would put both sides in its inverse. So we would say inverse of sine theta, inverse sine of sine theta equals inverse sine of 5 over 12. Now, those two things cancel each other out. They're inverses of each other. So we're left with just theta. This one, however, oh, my calculator app is getting in the way there, sorry. Let me move it over here for the time being. Inverse sine is just a button that we're going to have to press on the calculator. So what I'm going to do is shift, then the sine button, and you can see I get inverse sine. I'll often call it shift sine just to remind us where it came from. Americans often call it arc sine, but we're going to be calling it inverse sine because it is the inverse of the sine operation. So inverse sine fractions 5 on 12. Remember to close the brackets. 24.624. That number 24 is coming up a lot. Now, the question might say, write it to the nearest minute, in which case I click 27, well that's below 30, so it rounds down, 24 degrees, 37 minutes, 24 degrees, 37, 1 dash for minutes. And that is that question. Alright, I'm going to move the calculator back here and scroll down, but you can, whoops, scrolling on the right, pause it if you need to copy that down. Alright, so let's write some notes on them. I don't know why it does this, but it's often selecting 2 pens at once, and the only way to get rid of it I found is to hold down one of them. So, I won't write because inverse is going to be hard to write. Let's say, to undo a trig ratio, sine, cos, or tan, we call them the trig ratios, we use its inverse. sine, well, its inverse is sine to the -1, or inverse sine. That's how we say it. Cos, or inverse cos, inverse cosine, full name. And then tan, when we say tan, we're just pressing shift, tan, to get inverse tan. All it does is work back the other way. Just like we don't memorize the sine values, we let the calculator do it for us. Same with inverse sine, inverse cos, inverse tan. Just let the calculator memorize the values for us. We just need to tell it what the ratio was to begin with, and it'll undo it and give us the angle. I might just write that inverse trig functions. That's another name for them. Instead of inverse ratios, inverse functions. Give us angles. If you use inverse trig and then you write your answer in meters, you've probably made a mistake and you're probably not answering the correct thing, because inverse trig functions always give us the angle. Normal trig functions that we've been using give us a length, a side length. So that can be a good tip off to if you're making a mistake, if something's going wrong there. Alright, let's have a go at another finding an angle. So find the angle to the nearest degree. Oh, now let's go nearest minute. Why not? Just test out our new button. Alright, just pretend that little bit on the end there isn't there. Actually, can I write it out? I can, cool. Alright, right angled, of course. So theta, let's say this one is 16 and this one looks quite a bit longer. Let's say it's 28. First step is the same as always, label the triangle. So that's the hypotenuse. This 16 is next to my angle, so it's the adjacent. That one is opposite. Well, I care about using O and A because those have values. So that is tan theta, because I don't know it yet, equals, well, tan, you got to remember, is TOA, O over A, 28 over 16. Now, in the step above, I said that I used inverse sine on both sides, and I wrote it out. And that is what we're doing, but it is okay to skip writing. Let me use a different color. It's okay to skip writing this bit and just write theta equals inverse sine 5 on 12. That is perfectly fine to do. In fact, it's encouraged. So let me make sure I got room. So theta equals inverse tan 28 over 16, just fits on the page, barely. Move that over to 10. And now I need to write that in the calculator. So let's clear that. Shift tan to get inverse tan. 28 divided by 16. If you do the fraction key, you have to finish the bracket. I'm lazy, and also when I was growing up, the fraction key didn't exist, so we just used division. 28 divided by 16, because remember, division is the fraction, same thing. 60.255, but I'm not done because the question says to the nearest minute. So I'll press this button. 60 degrees, 15 minutes, and 18. Well, 18 is going to round down and get me 60 degrees, 15 minutes, because 18 seconds isn't over half a minute. It's slightly less. Alright, so I'll leave you with a class kick to make sure that we are understanding. Check your own answers on the last slide. I'm going to put the answers on the last slide. Just check that you've got it right. Put your hand up if you need help because you're not sure why you've got it right, but I'll let you check your own work, and that'll give me some more time for people who need that one-on-one assistance. After that, there'll be some textbook work to do. I know I've been giving you guys a lot. I'm going to send out a survey at the end of the week just to see what the workload's been like, if we need to dial it back or if you think you can handle a bit more. As we're all exploring this online learning thing together. But best of luck and get to it.